Yes. Okay, so the last panel for today, blockchains demystified. Could I invite Vlad back up on stage, and Henning for the heavy hitter. You got like top score today, man. Okay. Blockchains demystified. It's the last session for today.
Oh no. Because you were looking at slides here, weren't you? Let's press the present button. Where are we? Is there? Oh, there it is. So let's try this. This is Google Slides loading. It's not the projector. There we go. Should be. Wait. Here we go. This is probably just gonna. So I need to. I guess what I'll do is make I'll make two windows.
Maximize everything. It's gonna be fine.
Yeah, it's fine here, but the issue is that we can't see it also here. See, I want to see it both here and there. Sorry, guys. One minute. Just some technical difficulties. It's showing there and not here, and Ubuntu is hard to deal with all the screen things probably compared to just bringing it up again. Give me a couple years. Great. Oh, this is actually not going to be great. I'll figure it out.
I mean, okay, while Vlad is figuring out, you figured it out. Okay, cool. So I have this idea. So I would like to quiz the audience. Who here has used Bitcoin? Who here has Ether? Who has Ripple? Okay. Who knows what Ripple is?
So this isn't so bad.
Yeah. Who has heard of Tendermint? Awesome. Okay, cool. Who's got Dogecoins? No way. But it was a scam.
It was a fun scam. That's all that matters. Hey, I've got this one. Great.
All right, cool.
So we're going to give a talk that we hope will help you understand how to think about blockchain protocols and how to think and compare different blockchain protocols, and just get your mind around these things, which we sometimes all have different words to talk about it, and we talk about different protocols using the same words, and it's not always clear what the distinctions are, and hopefully things should be a lot clearer after this presentation. We're going to try to keep it not too technical, but also keep it very true. So
I'm doing the metaphors.
here we go. Demystifying the blockchain. Power, hype, reality. So we've seen, especially with Henning's opening talk, that there's like tremendous power with blockchains to be like censorship-resistant public agreement between computers. And there's a lot of interest in the space, and that's led to a lot of and because the interest kind of has come before a lot of the research and a consensus in academic circles, there's been a lot of confusions as to the reality of blockchains. So we're going to talk about and work through the power, the hype, and the reality. So there's actually two things that Bitcoin invented. It invented two completely independent inventions in consensus technology. One of them is called blockchain-based consensus, or blockchains, and the other is called economic consensus. So Economic blockchains are like this type of consensus protocol that comes to consensus via compromise rather than coordination. Instead of everyone talking to everyone to agree on the next change, someone will propose a change, and then everyone will agree saying that new change is better than what we've had before. Economic consensus, on the other hand, is this innovation that has allowed this consensus protocol to exist on the public open internet without a single network administrator, without a group of network administrators, without administration period. It's the economic consensus that allows blockchains to act as a public utility.
I would like to add something. I mean, I came here with an understanding that everybody has his own private definition of what a blockchain is. I really freaked out yesterday when I realized that Vlad and Peter could actually agree. That gives me a whole new trajectory of my research and learning, which is now I'm going to find out if Dominic might also agree with what they think.
He's over there. Maybe. Great. So we're going to go through the projects, and we're going to talk about them in this language of blockchains versus economic consensus, and we're going to go through them one by one and see if we can just say what they are. But firstly, let's talk about consensus. So consensus protocols, as we talked about a couple times today, and which we need to iterate over and over again because it cannot be clear enough, they're used to make one reliable computer simulated across many, many unreliable or untrusted computers. All of the nodes in a consensus protocol replicate some state of a ledger, a database, an application, and in a way that's like reliable, even if some of the nodes that are in part of the network misbehave. They can misbehave in arbitrary ways. As long as there's not too many of them misbehaving, the consensus protocol should still provide a coherent picture of the image of this application state, database, or ledger. So people use consensus protocols even outside of blockchains. And they've been around for a while, although the academic literature isn't too deep and wide. They're used in processors, distributed databases, and in flying cars, where basically it's very, very important that the engines agree on the inputs that all the other engines are getting, because and are all working reliably, even if one of the little computers fails, because you really don't want it to malfunction when you're in the flying car.
It's still a made-up example, right?
No. I saw this on the Discovery Channel.
Really?
Yeah, for real. This was before Bitcoin. Yeah, there's probably YouTube. Yeah, drones might use consensus protocols. Who knows? I mean, they should. It's better to have a replicated computer than just one computer if you have a really critical application. So, traditional consensus protocols are not blockchain-based consensus protocols, and they traditionally only come to consensus when a supermajority of nodes approves of the change. This makes them very safe. We call them forward secure. They will not fork in the way Bitcoin might. Because the supermajority agrees, before the change occurs, everyone will make the same change. There's not two supermajorities that make two different changes unless there's above a certain amount of faulty nodes. But in normal conditions, it doesn't ever fork. So, in these types of consensus protocols, if too many nodes are faulty or just go offline, or if there's a network partition, it kind of just stops because it can't guarantee the safety property that the change it's about to make will not be reverted and that clients won't disagree about it. Blockchains, on the other hand, they, like I mentioned earlier, they come to consensus through compromise. Someone will propose a block, and then that'll cause the client's fork choice rule to pick the blockchain that now includes that block. So people seeing this new block, even without coordinating beforehand to all agree on it, will choose this new fork. And then the consistency comes from the fact that all clients choose the same forks. So forks are blockchains. Every blockchain is a fork, and sometimes you might have two blockchains that share most of the blocks, and then there's a few blocks that they don't share. And we call them forks because they're kind of forks of the same blockchain.
I would like to dwell a little bit on the consequences. I mean, first of all, it's important to see that this traditional consensus protocols was that was basically how you would solve this kind of consensus problem. And it has a very strong scalability problem in that it works for tens or 100 maybe. And then you get a problem that you cannot have the communication efficient anymore between all the nodes that have to agree before everybody makes a step to a new state in lockstep. But it just slows down to a degree where it's not usable anymore. While Bitcoin from the start was designed to have nodes beyond that limit and came up with something here that was a completely new paradigm. There was something where researchers beforehand didn't want to go, which is like, yeah, let's just risk that we get out of sync. And then just let's try to heal it as good as possible afterwards. And that's exactly what Bitcoin does. And this is why it can do that with 5,000 nodes, where they will disagree pretty often who is actually now having the right truth, but it doesn't matter because it's instantly healed as soon as it becomes clear which path seems to be the more promising one. But this has also strong consequences because especially in fintech, you might not find it desirable that you go forward with the truth no matter what everybody else might think, and are not able to tell even if you're alone in what you think is the truth, or at least in a kind of sizable minority or whatever, and all of a sudden the truth changes. So you never have a 100% guarantee about what is actually the committed state in any given moment. It could just turn out you're on the smaller fork if you're unlucky.
Yeah, and although it is important to note that there exist blockchain protocols that do have finality, and there also exist blockchain protocols that don't have this nice property that the overhead is really low, even as you scale the number of nodes up. The pattern that defines blockchains is the idea of a fork choice rule, and Bitcoin is like only a blockchain. It doesn't involve any coordination, but we're kind of working on blockchains that have also finality and also this property that you come to consensus through compromise. So the characteristic of these blockchains then is that if there's a network partition, they will still make their application states available to the clients. Clients will still be able to make a transaction, and a block will appear showing them the result of that transaction. They're also more decentralized in this than traditional consensus protocols because to create a change, you don't require permission from a majority. One way to think about it is that the size of the center of a network is related to the number of nodes that you have to remove to make it stop. In a fully centralized node, if you remove one node, it stops. With a traditional consensus protocol, if you remove enough nodes to prevent a supermajority from forming, it stops. In a blockchain-based protocol, most usually, you have to remove all but one node for it to stop. So economic consensus is this other property. So, and basically it lets nodes who don't trust each other, don't know each other, and aren't set up by a network administrator to still come to consensus. And the reason that they do this, the way that they can do this is by kind of knowing that if other nodes were to screw up and act in a way that's bad, it would cost them a lot of money. It's this kind of trust through the fact that we know that everyone has expenses, and if they don't make up their expenses, then they're going to lose money, and losing money is hard for an attacker to do on a massive scale in order to disrupt the network. Hopefully that's clear. I'm sure we'll talk about it more. So economic consensus can be used to provide public utilities. It can be used to provide like really, truly public networks that aren't administered. Whereas without economic consensus, you can't really do that because you can't control the composition of nodes without an administrator. We have this trend called like permission blockchains, where people want to have like blockchains in a non-economic context, and they require like an administrator to say who is allowed to be a node. And you can use economic consensus in a private context by just insisting that the nodes who you chose to be part of the consensus would lose money if they misbehave. Although, if you own the servers yourself, then that might be you causing yourself a cost. But if you choose servers, say across different banks or something, it might make sense to incentivize them to keep these nodes online.
And to be a little concrete, I mean, that's part of the thing we want to bring across. Economic consensus is what is actually used in the moment in Bitcoin and in Ethereum. And even with the changes that will come to Ethereum, it will still be based on economic consensus. And what we're seeing is that the approach to have a public blockchain as opposed to private blockchains that are also interesting, but for public blockchains in the moment, it's economic consensus.
Yeah, and it's also worth noting that the reason that Bitcoin was such a success isn't through like amazing use of blockchain technology, but through the fact that it is a public protocol that has this economic consensus. I mean, blockchains favor availability in the event of network partitions, but Bitcoin, which actually ends up meaning that you can make blocks pretty quickly and still come to consensus. But Bitcoin makes blocks every 10 minutes because of the particular architecture. But it's really the economic consensus that has generated all this interest in this space, and thankfully has caused a lot of renewed interest in the consensus space more broadly. So there's a couple of ways that like we know of to do economic consensus. Proof of work is Bitcoin's pioneering example, which is that the strategy is to make the creation of blocks very computationally expensive, and then what happens is that Bitcoin compensates you for making a block in the correct location, and so everyone ends up making blocks all in a chain together because they only get compensated for that expense if they all work together. If say a faulty miner would create a block not on the main chain, they would incur the expense, but they wouldn't be compensated for it. And so their fault would be expensive. And then there's another class of protocols called proof of stake, which tries to use kind of digital assets in the consensus to make faults expensive. Traditionally, proof of stake meant that you'd have to like just buy up coins in order to create blocks, and that would be expensive for you to do unless and it would be expensive for you to attack the system because then you would like lose value of your own coins. More modern proof of stake systems use security deposits, where not only do you need to buy out coins, you need to place them in deposits so that the protocol has like direct control over your coins. And if the protocol thinks that you've misbehaved, it will remove some of these coins from you, making you bear this expense.
It's interesting in that context that the stake, though, does not necessarily only have to be within the system. It's one criticism of proof of stake that it doesn't really help you with any motivation for an attack that is motivated from an outside incentive to bring down the whole system. But in the context of private blockchains that are interesting for IoT or fintech, you see that reputation, for example, or money paid into a bond can equally serve as a stake to give you incentive to behave as a miner or a validator.
So now we're going to start going through the projects and saying whether they're blockchain based, whether they're economic, and getting a nice little discussion about their properties. And hopefully this should clear up kind of the taxonomy of the space for you.
Yeah, we picked some of the names that people will probably be running into, and Bitcoin we probably don't have to explain. I think Ripple is also clear. Stellar is an offshoot from Ripple, if I can say that, in the sense that it has a stronger social focus maybe. Hyperledger is something in the banking side. Ethereum, everything. Everybody has heard about that, I guess, and yeah, we'll explain the rest.
So let's just go through them. So Bitcoin, the first blockchain, it's Satoshi Nakamoto's epic creation, and its stated purpose by most of the like ardent supporters is to like act as a public currency to disintermediate banks.
That's in the white paper also, as stated purpose. So.
Oh yeah, okay.
Not just the fans. He said it himself.
Satoshi Nakamoto himself. Zero cash. It's Zero cash is also a blockchain-based protocol, and it's basically designed to be anonymous money. It's like Bitcoin's dark cousin.
Yeah, it's the only slide we have about zero cash because in many aspects it's very similar to Bitcoin, but it's an evolution in the direction of really angering the regulators.
Ripple is going to replace Swift. I'm pretty sure that's a publicly stated goal as well.
Is it?
Yeah.
Oh, I didn't know. Interestingly enough, though, Ripple is along for a very long time, and it's probably their third or fourth pivot in what they actually want to be. I guess they positioned right to take them on, but it's not how they started.
And now Stellar. Stellar is like Ripple, but it's for banking the unbanked. So the kind of the social motivation is different. Protocol is very similar.
Hyperledger is a protocol that is designed for banking and a private network that's never been made for... Oh, that's funnier in Hong Kong than in London, it seems. Interesting. For London, I was asked to not show a naked female belly button, but well. So anyway, so wait a little bit with Hyperledger. Hyperledger has been bought by Blythe Masters company, and they are successful already in connecting banks and with a private network. It's a very simple protocol that is really focused exclusively on the very traditional way to build a communication between different players, and it doesn't really care about those more interesting things that even Bitcoin has, where a transaction is a script.
So Ethereum is a public smart contracts platform.
What's that?
It aims to be a place where you can program functionality into the blockchain using like a programming language that programmers are like generally.
But Bitcoin has that too.
It's Bitcoin. You have to write in the opcodes rather than be able to like write in a higher level language that compiles down to the opcodes.
So you could write a high level compiler for Bitcoin and have the same like Ethereum.
No, you can't.
Why not?
It's the opcodes have all sorts of weird functionalities.
It's really fun. Okay.
Tendermint is also a public smart contract platform, although I think they might be pivoting to do private consensus. They have an EVM, and it's notable because they're using security deposits as for proof of stake protocol.
Eris, the goddess of strife, started probably as a clone of Ethereum. Was also pivoting away from Ethereum at this moment, if I understand that right. And the idea here was to have a focus on making the consensus protocol parameterized, so that you could have a special customized setup for every individual chain.
So now we're basically going to go through them again and providing this like little taxonomical kind of quickly saying whether private or public, whether they use traditional consensus protocols or blockchain protocols, whether they're just a transaction network or whether they have this kind of smart contract virtual machine environment. Here we go. So
now we're recycling those images because they're so cool, and it's for a purpose, because we felt like maybe that's a way to really get an understanding in a short period of time. So next time you run into those different buzz names, you really have a good memory what it's all about. And yeah, so Bitcoin.
Bitcoin is public, decentralized, and it has a bit of scripting. So we say that it has this little virtual machine thing.
Yeah, it's the blockchain, right? It's what started, and it's the reference of what a blockchain should be, I guess, even if many people nowadays have their own definitions. Mm-hmm. And it's not often said that it has a virtual machine, but technically it has. And
So Ripple is a private transaction network with built-in currency conversions. For the longest time, I actually thought that Ripple uses a traditional consensus protocol, but it turns out that they have a blockchain-based consensus protocol with the fork choice rule. That's, I guess, something that they don't really advertise that much in their literature. They try to make their consensus seem very safe, but it does have the fork choice rule. So if there was a partition, then nodes would disagree. So that's something to know.
But still, in a certain sense, it's not completely decentralized because it works with a whitelisted validator set. So it's not as open. It's not supposed to be as open. It's part of the whole business idea there that you know who are actually the validators or the miners, however you call them.
Stellar, it's the same, only it banks the unbanked.
It really is. It's a fork. It's a one, right? What do you say? It's not the same? They don't.
Cool. Is it blockchain based? Is it safe? No, it's safe, isn't it? Do they have a traditional consensus protocol? Kind of. I'll read the paper. It'll be federated? Okay. So it could still be a traditional consensus protocol or a blockchain-based consensus protocol. It's sort of a hybrid. Okay. I'll read the paper. Sorry about this. Things change. Things change fast in this space.
Yeah, Hyperledger is really completely based on traditional consensus. It's they are just genius with branding because they call it a blockchain, completely riding on that hype and sell something that absolutely works for the use case that it's advertised for. It's not really a blockchain, but it doesn't matter. It was the right time to sell it, and they sold it, and it works, and it has customers and more traffic than some other blockchains, I guess.
Yeah, they have a real business plan. It's amazing. So Ethereum is public, blockchain-based, smart contract platform with the virtual machine.
Yes, and I would like to stress that Ethereum really has a virtual machine that is Turing complete, and can do all sorts of things, and this is why it can be this blockchain of blockchains.
And Tendermint is similar, only it uses a traditional consensus protocol, but also has virtual machine. It's also public, although they might be pivoting.
Ares has started to work with Tendermint. The obvious field of research that many people are running into is to see how can we use the technology that's really developed for the public blockchain for a private blockchain. And they found that Tendermint is probably researching the same way. Interestingly, Jay, who's doing Tendermint, was first trying it, that he was using Ethereum and trying to build the Tendermint consensus into Ethereum, and then pivoted to use the Ethereum VM and build it into Tendermint. While I would say that the VM is probably 90% of a project and the consensus is actually 10.
Not sure about that.
Some people disagree.
Yeah. It's hard to say what's more work when Ethereum's already done the virtual machine and you just import it in.
So talking about the virtual machines on the next slide. So smart contracts, we had that earlier, actually need some kind of code possibility, and so you have to have a virtual machine, you have to have code that's executed, and you also have to have some kind of cryptocurrency, however you call it, the token of the blockchain, and something that they can actually transact. What they also need, and which is something that I find is generally spoken not enough of, is they need to have some kind of interface to the outside world that actually triggers something that makes them execute whatever the logic is. And that's often called Oracle.
Oracles basically provide information that can't be verified by the contract itself to the contract. So classic examples are like price feeds of external assets or the weather in San Francisco.
Which is also, because we had that earlier, which is also a point why it becomes so powerful when you have when you have shares issued, for example, or any kind of assets issued directly on the blockchain, because then you don't necessarily need an oracle. Then it's all part of that digital world. And that's what makes the things really fast then, and really potentially complex. So for smart contracts, the interesting thing to see is that we really only deal it with two different VMs. And the Bitcoin VM is not even taken seriously as a VM usually, and the efforts, in my view, to create real smart contracts on top of Bitcoin are heroic, but misguided also. And I understand how Peter means it, which basically means he's not here.
No, he's not.
That's why it's silent. The way that Peter means it, it makes complete sense, of course. Peter understands a lot more of that than I do. Still, what we're seeing here is that we have the Ethereum VM basically being the basis of Ethereum, Tendermint, and Eris. And it's the only VM that actually really can give you smart contracts. And this is why when you go to a hackathon and give people free choice of any technology they might use and certain kind of smart contract leaning tasks, they all use Ethereum because it makes sense.
And now we're going to go through and say whether each of them are economic again. I mean, this time with nice little logos. So, Bitcoin is economic because it makes faults expensive by making changes expensive. Ripple is non-economic because the nodes that are nodes maintain a trusted node list, and faulty behavior isn't punished through direct costs to these nodes. Stellar, just like Ripple, not economic. Hyperledger, also non-economic. For these like interbank clearing, you know, they don't really want to get charged by their own protocol when the node goes down. Ethereum is public and economic. Right now it uses proof of work. Our plan is to switch to proof of stake sometime in the next year to 2 years.
Which, interestingly, is really, really different, but also economic.
Yeah, definitely economic. Tendermint is also economic. And Eris is non-economic, although they're going to be using the Tendermint stack in a non-economic way. So instead of like using security deposits, you just have like the deposit as your permission to produce blocks.
So, does anybody have any question? Sure.
I'll do the run. Who's first?
Yeah, just a question about Aries. Like this description you gave now is like that. Is that after the recent rebranding or pivot or whatever you want to call it?
Can you say that again? Sorry.
If the description of Aries is like after the recent rebranding or second pivot or whatever you want to call it.
Yeah, so Eris is, after the rebranding, they're traditional consensus protocol. It's not economic. So
Okay.
And they
No,
have a virtual
yeah, I
machine.
was just asking because it changed. a
Yeah,
few
it used to be
times.
blockchain based, and now it's now it uses a traditional consensus protocol.
Okay, thanks.
If you were designing a clearance and settlement system using the technology, would you, for banks, for example, some in the room, would you want to have an economic incentive system where you're actually penalizing people for breaks? An account that can be debited?
No.
Why not?
Yeah, we can talk about that in length. I'm really interested in that, and anybody is invited who's also interested in that. In short, there are existing incentives in the business for companies to not behave badly, and it does not really make sense just for the fun of it to create a new incentive on a level that's actually not even as powerful as that you don't want to lose your reputation or have anybody else stop dealing with you.
Yeah, so all of the nodes in one of these bank networks are going to be like known to the banks. They'll be operated by someone that the bank knows. Otherwise, they wouldn't pay them for that. And so and then if you know who this entity is and you have a legal relationship with them, then you can use like legal means for punishing them for being faulty. Or
The reason I'm asking is in settlement systems like LCH ClearNet and DTCC, I believe there are penalties for breaks, and your account can be debited. So that's the only reason why I was curious.
I don't know that. If that's the case, that's also an example, though, for existing mechanics, who are also probably not automatic. We're talking about something that is completely automatic and works with entities that are completely anonymous, which is absolutely not the case when we talk about a private network for interbank clearing.
one thing you didn't mention was chain and its implementation through like APIs. How do you see that in conjunction with things like the virtual machine and your commentary about Ethereum being easier to work with to build apps on top of than the Bitcoin blockchain? How would you classify the work that Chain's doing?
Yeah, so I would like to give an allegory there. I think it's clear that everything that can be done with HTTP can be done with FTP. And that's just my personal belief, but I believe that having stuff on the blockchain and having code actually, if not in the blockchain structure itself, but closely associated in state, so that it's kind of part of that state package that nodes send around to each other, is probably, it's very likely going to make the difference in productivity, in robustness, in transparency, that might be as high as if you would try to implement a web server using FTP. You could do that. Technically, semantically, somehow on some level, it's completely the same. It's just completely not productive. And this is why we have HTTP in the first place. And within IBM, there was this argument. When HTTP came up, it was like, we don't need that. We have FTP, and it's not adding anything, right? So in this case, although you could say, hey, on a certain level, that really absolutely doesn't matter where the actual code is. It's just what matters is that we have the hash in the blockchain. It still, in my view, might make the difference, but I don't know.
I have a very simple question. There was a slide about different parameter choices of different kind of blockchains, and it was gone through very quickly. Could you show it again? And if possible, can you explain how those design choices being chosen in different blockchains that you just show us?
Actually, that's pretty much what we did. I mean, those seals that you have there and the text at the bottom, that is the application of those differences that we had listed there. So that's the distinctions you meant, this list? Yeah. So this is very much what we discussed then after, how the different blockchains are dissimilar with that.
I've read something like about permissionless, and there was probably a bunch of others.
It was a different slide.
No. Like read it from some websites. And is there any other important design choices that that's not included here?
Yes, there are lots.
Yeah.
I mean,
Is this the only taxonomy, or there are others?
This is just what we decided to focus on for this talk. You can endlessly discuss the fine nuances, and sometimes in specific use cases, all of a sudden they make huge differences. And this is what makes this whole field sometimes like a bit of a minefield.
And here we kind of use private versus public to talk about permission versus unpermissioned. Permission is kind of a word that people like to use now. I personally prefer private versus public because it kind of it tells you whether or not there's a network administrator.
Right.
I see. Thank you.
Thank you.
Sorry, when you use proof of stake, do you stop creating new currency?
That depends. If the proof of stake design space is very, very large, it's kind of up to you as the protocol developer.
But I thought you don't.
I personally prefer not to, because I think issuance is kind of funny economics, where you're kind of basically taxing all the holders of the tokens in order to secure the network. But it does make some edge cases potentially less fatal to the network. So if transaction fees were to drop to zero, if you issue, then it might be more secure than if you don't issue.
I mean, the idea originally comes from having to pay in a stake and then proving that you have paid for having the allowance to take part, which then shifted towards, we can take the native token, right? And then shifted towards, we can as well just hold back the reward for the blocks that you would get. So actually, it became more and more elegant and more, but it wasn't about creating actual rewards, right?
Yeah. I mean, security deposit-based proof of stake is based more on like disincentives than incentives, and so whereas like proof of work fundamentally has to be based on the issuance of coins, and like this, because the disincentive is extra protocol. So it's kind of perhaps more elegant to use only a small amount of incentive and a lot of disincentive, because that way you can make faults very expensive only when they occur, rather than making updating the state always expensive and compensating it always.
So I'd like to thank our presenters, and feel free to come up and ask them any questions. And all our panelists today, Pindar for being our MC, Cyberport for hosting us, and actually in particular Perkins Coie and Brian Cave, who have been a part of our workshop since the very beginning, and huge supporters. So, and thank you all for standing through. Yeah. And we start at 9:45 tomorrow. We've got a full day, really amazing speakers, and hope to see you guys there.
9:45. See you tomorrow morning. Have a good evening and enjoy Hong Kong.